Okay, so I'm going to talk a little bit about colored objects under colored lights and what happens when we put a colored object under colored light. And we have to start that discussion reminding ourselves that, oh, that doesn't help, reminding ourselves that what does it mean to have a colored object? We're going to continue to use in our discussion the model of light that says white light, the light we normally in our environment, is made up of red, blue, and green. And so let's imagine that it's the fall-ish time, yes, close to winter, but we have a red apple, a green apple, and a yellow apple. So our red apple, so this is a red apple. Red light comes down, hits the apple from the sun. Green light comes down, and blue light comes down and hits the apple. So we have green light hitting the apple, blue light, and red light. What happens? Well, the red apple reflects the red light and it hits my eye and I see red. The blue light gets eaten up and the green light gets eaten up. And that's due to the chemical makeup and the molecular makeup of the apple itself. When I shine white light on it, I'm shining red, blue, and green. It's reflecting the red and absorbing the blue and the green. Let's do a couple more. Oh, green apple, well, red comes down, green comes down, blue hits the apple. I see a green apple because green light is reflected. That is a property of the apple. The green light's reflected and the red light is not reflected, nor is the blue light. They're absorbed, eaten up. Yellow, well, same thing. A red light comes down, blue light comes down, green light comes down. And in the case of the yellow apple, I'm seeing yellow, which means I'm seeing both red and green at the same location in space. So the yellow apple reflects both red and green and absorbs blue. So we talk about objects being a certain color because of their inherent molecular properties that absorb or reflect certain wavelengths of light. But we visually talk about them in color because we assume white light is being presented to them. What happens if I don't present white light to one of these objects? What if I present a different color light? Let's imagine that I have a red apple, and instead of providing it red, green, and blue or white light, I just shine blue light. Well, a red apple absorbs blue light. It also absorbs green light and it reflects red light, but there's no red or green available. So it doesn't do anything because there's none of those lights available, but it does absorb the blue light. So if I were to look at this object and blue light was shining on it and I saw this object that absorbed all the blue light, it looked like a really gross apple. All the light would be absorbed. Nothing would be hitting my eye. And what do I see? That apple's black. So nothing hits my eye, so I perceive it as black. What if I did the same thing with the green apple? So again, in this case, let's shine red light on the green apple. So I don't have blue or green. I don't have green, so nothing's reflected. And there's no blue to absorb. So if there was, it would, but there isn't. And the only thing that it can do anything with is red, and it absorbs red. Well, red goes in and doesn't come out. And again, the apple appears black. Nothing is reflected. So my green apple is black. What about a yellow apple? Let's do red again for a yellow apple. Well, there's no green light to reflect, so that isn't even an option. And there's no blue light to absorb, so we don't really have to talk about that either. There's only red light. And a yellow apple reflects red light. And so this apple looks red because it's reflecting the red light that it's presented with. It doesn't look yellow because there's no green light that it's being presented with, but it still will reflect that red. So we can change the color we see of an object by just shining different lights on it, by shining different lights on it. And how do we shine different lights on something? Well, we put a filter over a red light. So this combines that idea of filters and colored objects under colored lights. So let's make some predictions and observe this in practice. We have two examples of this, and it'd be good to pause the video to make your prediction. So I have a green object, and it's just a sheet of paper. And I have a cyan object. Again, just a sheet of paper. So I have a green object, and I have a cyan object, my two objects. And I'm going to put them under different lights. I'm going to put them under a magenta light, a blue light, and a cyan light. Okay. So cyan, let's start with the cyan object. So I want you to predict, what will a cyan object look like under a cyan light, a blue light, and a magenta light? So pause the video, make your prediction. All right. I have my cyan object. A cyan object reflects blue and green, absorbs red. A cyan light is blue light and green light. So I'm providing this cyan object with blue light and green light. It reflects both blue light and green light, and we see that it remains cyan. The color of the surround and the color of the object are similar. Okay, so it's a cyan object, will appear cyan under a cyan light. That's not too hard of a stretch. What about my blue light? All right, so my blue light, sort of creepy, I'm just this head. So my blue light is just blue light. My cyan object will reflect both blue and green, but I'm not giving it green, I'm just giving it blue. What should it do with that blue light? Well, it should reflect it, and I should see blue. And we can kind of see that that blue is similar to the paper. What about magenta? Well, magenta is a red light and a blue light. My cyan reflects red and green, blue and green, but I'm not given green. It absorbs the red, so it'll take the red away, but it should reflect the blue. And I should see a blue sheet of paper, and we do. So my cyan object is blue under magenta light, blue under blue light, and cyan under cyan light. What about my green object? What about my green object? Well, cyan is blue and green light being presented, and my green object reflects green, but eats the blue. So I should see green, and I see green in my cyan. My green object reflects green, but absorbs blue. So when I give it blue light, I should see black, and my object turns black. It's absorbing the blue light that's presented to it. My magenta light, well, that's giving the object red and blue. A green object absorbs red and blue light. And so my magenta light should also make my green object appear black. So when we're looking at colored objects under colored lights, we want to dissociate the two pieces to make the analysis easier. The first thing to think about is, what is this color do under white light? What does it reflect and what does it absorb? And then look at what lights you're provided. What am I given to this object, and what will it do with what it is given? Okay, so that is colored objects under colored lights. Good job.